projects. In this video, we are going to explain about the project, which is an efficient network intrusion detection system for distributed networks using machine learning technique. Introduction of the project. As computer networks expanded and became integral to various sectors, the threat landscape evolved as well. The increasing connectivity made networks susceptible to a wide range of security threats, including unauthorized access, malware, and denial of service attacks. The project focuses on the development and implementation of an intrusion detection system, which is a crucial software designed to monitor network activities for signs of unauthorized access or abnormal behavior. The IDS plays a pivotal role in maintaining the security of computer networks by routinely inspecting data transmissions and altering administrators to potential intrusions. The IDS is broadly categorized into two classes, which is network based and host based. Network based IDS specifically targets the monitoring and analysis of network behavior to identify anomalies. This classification further branches into signature based detection, which identifies known attack patterns, and anomaly based detection, which identifies abnormal behavior by learning over an extended period. The project acknowledges the challenges associated with detecting distributed denial of service attacks, emphasizing the limitations of both signature based and anomaly based detection methods. The dynamic nature of DDoS attacks, with attackers frequently changing strategies, poses difficulties in accurately defining attack behaviors, making traditional detection methods less efficient. To address the limitations of traditional detection techniques, the project proposes a hybrid solution that combines both signature based and anomaly based methods. Leveraging recent advancements in artificial intelligence and machine learning, the system integrates random forest algorithm and principal component analysis, which is PCA, for feature selection, enhancing the effectiveness of the NIDS. Objective of the project. The primary goal is to create a network intrusion detection system with a focus on the modularity and reliability. The NIDS will be specifically designed to effectively counteract distributed denial of service attacks with distributed environments. The primary aim is to address the distinct challenges associated with detecting DDoS attacks within distributed networks. The focus is on preventing unauthorized nodes from disrupting service access while ensuring the availability of network nodes. Objective is to implement and integrate diverse machine learning models including SVM, naive Bayes, logistic regression, decision tree, random forest, and PCA-RF into distributed denial of service network intrusion detection system to enhance its accuracy, efficiency, and robustness in detecting and mitigating security threats within distributed networks. The key objective is to employ the random forest algorithm based on classification technique in the traffic detection module. The aim is to achieve optimal feature selection, enhancing the accuracy and efficiency of identifying distributed denial of service attacks. To implement this project, we need software and hardware requirements. Coming to hardware requirements, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. To implement this project, we have designed various steps in the flow of work. The first step is importing the packages. This module involves importing the necessary Python packages and libraries that will be used throughout the project. We have imported NumPy for numerical operations, Matplotlib and Seaborn for visualization, scikit-learn for machine learning, Flask and SQLite for web development. The next step is exploring the dataset. In this module, NSL-KDD dataset, which contain network traffic data for intrusion detection, is explored. This includes understanding the structure of the dataset, inspecting sample records, and identifying key features. Data processing. Here, the raw data is converted into a pandas data frame, which is a popular data manipulation tool in Python. Columns that are deemed unnecessary or irrelevant for the project are dropped to streamline the dataset. The next step is visualization using Seaborn and Matplotlib. This module involves creating visualizations to gain insights into the dataset. Seaborn and Matplotlib are used to generate plots, charts, or graphs that helps in visualizing patterns and distributions within the data. Label encoding using label encoder. Categorical data is often converted into numerical format for machine learning models. The label encoder is employed to encode categorical variables into numerical representations, making them suitable for model training. Feature selection using select percentile. Feature selection is crucial for building an efficient model. Select percentile is a method used to choose the most relevant features based on the statistical test. thereby reducing dimensionality and improving model performance. Building the model. This module involves building machine learning models and defining the parameters of those machine learning models. Training the model. The selected model is trained using the pre-processed dataset. This involves feeding the model with the labeled data to allow it to learn patterns and relationships between features and outcomes. Flask framework with SQLite for sign up and sign in. Flask is a web framework for Python and SQLite is a lightweight relational database. This module integrates Flask and SQLite to create a simple sign up and sign in system for users interacting with the application. User give input as feature values. User provide input in the form of feature values relevant to the model. These features represent characteristics of the network traffic for intrusion detection. The next step is pre-processing the given input for prediction. The input provided by the user pre-processed to ensure that it aligns with the format expected by the model. This include encoding categorical variables, scaling numerical features, etc. Trained model is used for prediction. The pre-processed input is fed into the trained machine learning model to make predictions. The model leverages the patterns leading during the training phase to predict outcomes based on the provided input. Final outcome is displayed through frontend. The results of the predictions are displayed through the frontend of the application, providing users with the information about the model's assessment of the input data. Algorithms which are used in the project are support vector machine. It is a supervised machine learning algorithm used for classification and regression tasks. It works by finding the hyperplane that best separates different classes in feature space. SVM can handle both linear and nonlinear relationships. It is chosen for its effectiveness in handling high dimensional spaces, making it suitable for intrusion detection where network traffic data can have numerous features. SVM's ability to find complex decision boundaries is valuable for identifying patterns indicative of security threats. Naive Bayes. It is a probabilistic algorithm based on Bayes' theorem with the assumption of independence between features. Despite its simplicity, it often performs well, especially in text classification and other tasks with categorical features. It is computationally efficient and particularly effective when dealing with the discrete features. In the context of intrusion detection, where certain network behavior can have discrete and categorical, naive Bayes provides a quick and efficient classification method. Logistic regression. Logistic regression is a classification algorithm used for binary and multi-class problems. It models the probability that an instance belongs to a particular class using the logistic function. Logistic regression is well suited for binary classification tasks. In the project, it is employed to predict whether a network activity is normal or potentially malicious based on the learned probability thresholds. Decision tree. It is a tree-like model where each node represents a decision based on the value of a particular feature. It recursively splits the data set into subsets until a stopping criterion is met. Decision trees are interpretable and can capture complex relationships in the data. In the context of intrusion detection, a decision tree can help identifying decision rules for distinguishing between normal and suspicious network activities. Random forest is an ensemble learning algorithm that builds multiple decision trees and combines their predictions. It improves accuracy and reduces overfitting compared to a single decision tree. Random forest is chosen for its ability to handle large data sets and its robustness in dealing with noisy data. By combining multiple decision trees, it provides a more accurate and suitable, a stable intrusion detection model. Principal component analysis with random forest. Principal component analysis is a dimensionality reduction technique used to reduce the number of features while retaining the most important information. When combined with random forest, it forms PCARF, which is principal component analysis with random forest. It is beneficial for feature selection, reducing the computational load and enhancing the model's ability to handle high dimensional data efficiently. By retaining the most relevant features, PCARF contributes to improving the overall performance of the intrusion detection system. As an extension, we applied an ensemble models to produce a more robust and accurate final prediction. Also, as an extension, we built frontend using Flask framework for user testing and authentication. We have evaluated the project using different performance metrics, which are accuracy, precision, recall, and F1 score. Here we have comparison graphs for all those metrics. This is accuracy comparison graph. Accuracy is a measure of the overall correctness of the model. It calculates the ratio of correctly predicted instances to the total instances. Here on x-axis, we have accuracy score for each algorithm, and on y-axis, we have algorithm names. This is precision comparison graph. It is also known as positive predictive value. It is a measure of the accuracy of positive predictions made by a model. It calculates the ratio of correctly predicted positive observations to the total predicted positives. This is recall comparison graph. Recall is also known as sensitivity or true positive rate. It measures the ability of a model to capture all relevant instances. It calculates the ratio of correctly predicted positive observations to the total actual positives. This is F1 score comparison graph. It is the harmonic mean of precision and recall, providing a balanced assessment of the model's performance. It is particularly useful when there is an uneven class distribution. Algorithm which performs well among all these metrics will be used for final prediction. To execute the project, first we need to open the code folder which contains source code file. This is the code folder of the project. This is the dataset folder in which we have datasets, and we use those datasets for training the algorithms. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. And this is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. These are the model files which contain the algorithm information and that will be loaded into the project code during runtime. And this is the notebook file, which is IPYNB file, and it is a Jupyter notebook file which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. This is sign up file. This file is the database file used to store the user information. Now to execute the project, we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. Here we can see that current directory is changed to the code folder's path. Here we need to type the command python space app.py and click on enter. This will compile app.py file, and this will perform a Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application at the local host and the port number unless configured differently. So this is the local host and this is the port. Now we need to copy this local link provided by the framework and paste it in any web browser. I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and then click on enter. This is the web page of the project which is displayed in the browser. And this web page is built by using the Flask framework. And now we need to click on sign up link. Here we need to enter all the sign up details if we are signing up newly. I have already signed up and I have an account in it, so we'll directly click on sign in. Here we need to provide our credentials, which are the username and the password. So I'm giving my username and the password. And now we need to click on login. We have logged in successfully. Here we can see the parameters which are need to be entered. Based on the given parameters, we will get the prediction whether attack is detected or not. Prior to entering the parameters, we will understand them. So here we have service, which is a type of network service or a protocol. Different services exhibit unique traffic patterns aiding in anomaly detection. This is flag. It provides insights into connection states for detecting unusual patterns or potential threats. Here we have SRC bytes, which monitors data volume for identifying abnormal data exchanges, which is source bytes transmitted. Here we have DST bytes, which are destination bytes transmitted. It monitors data volume for identifying abnormal data exchanges. This is count. It is a number of connections to the same host in the past 2 seconds. It identifies patterns of repeated connections indicative of certain attacks or suspicious. Here we have error rate. It monitors SYN errors associated with potential malicious connection attempts. This is same SRV rate. It aids in detecting patterns of service-specific tasks or abnormal behavior. Here we have different SRV rate. It aids in detecting patterns of service-specific attacks or abnormal behavior. Here we have DST host SRV count. It provides insights into service distribution on destination host aiding in anomaly detection. Here we have destination host same SRV rate. It provides insights into service distribution on destination host, aiding in anomaly detection. Here we have destination host different SRV rate. It is a percentage of connections to the different services on the destination host. This is destination host error rate, which is percentage of connections with SYN errors to the same host. So now we will enter the values. Service is 12, flag is 9, SRC bytes are 36, destination bytes are 0, count is 2, error rate is 0, same SRV is 1, different SRV is 0, destination host SRV count is 171, destination host same SRV is 1, destination host different SRV is 0, and destination host error rate is 0. And now we will click on predict. Here we got the prediction as there is no attack detected and it is normal, which means attack is not detected. Now we will enter the parameters again but with the different values. So click on home. Service is 24, flag is 5, source bytes are 0, destination bytes are 0, count is 42, error rate is 1, same SRV is 0.26, different SRV is 0.1, destination host SRV count is 44, destination host same SRV is 0.17, destination host different SRV is 0.05, and destination host error rate is 1. Now we will click on predict. Here we got the prediction as there is an attack detected and the attack type is DDoS. In this way, if we enter the given parameters to the system, then the system will detect whether attack is detected or not. Now click on sign out. Conclusion of the project. The project successfully delivers a comprehensive intrusion detection system incorporating diverse machine learning algorithms such as support vector machine, naive-based logistic regression, decision tree, random forest, and PCA-RF. This multi-algorithmic approach enhances systems' ability to accurately identify and mitigate security threats within distributed networks. By integrating principal component analysis with random forest, the project achieves efficient feature selection and dimensionality reduction. This not only enhances the system's computational efficiency but also contributes to improved accuracy in detecting distributed denial of service attacks. The implementation of the Flash framework coupled with the SQLite for sign up and sign in functionalities provides a user friendly interface. This allows users to interact seamlessly with system, input feature values, and receive predictions regarding network security. The project employs robust evaluation metrics such as accuracy, recall, F1 score, precision to assess the performance of machine learning models. Experimental results showcase high accuracy with the suggested detection algorithm, achieving higher accuracy, demonstrating the effectiveness of the proposed IDS.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.